Hello everyone, welcome to this lecture number 5 of this unit Flexible Manufacturing System. This is Mr. Suyog Patil working as Assistant Professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Hyderabad, Ichalkandi. Today we are going to see the robotic programming languages. So first of all we will see what is meant by robot programming. Okay. So therefore robot programming is a set of defined or again defining a desired motions so that the robot may perform them without human interventions. So therefore robot programming is nothing but defined a desired motions, okay, certain motions for this robot, and that robot may perform these instructions, these motions without the human interventions. So that is nothing but the robot programming. So according to this Robot Institute of America RIA, this robot can be defined as a programmable multifunctional manipulator designed to move the material, parts, tools, and other specialized devices through a variable programmed motions, okay, in order to perform the various tasks. So therefore, to perform these various tasks in this industries or in the day-to-day human life, so a machine is defined or machine is designed, okay, and that machine can perform the various operations by using this programming languages. So that is nothing but the robot according to this RIA. So next one it is robotic programming. So there are three methods of this programming. One it is called as manual teaching, second lead through teaching, and programming languages are also certain languages are there. So in this manual teaching, so we have to define some point to point locations or point to point instructions. Okay, so here we can see this robot is in this case pick and place type of the robot is there, so it is taking from this point and it is placing on this conveyor line. Okay, so in this pick and place type of the robot, so point to point motion is defined from this point to this point, this point to this point. Okay, so point to point motion is defined here. So it is the case of this manual teaching. Set of instructions are very simple in this point to point applications. Second one it is lead through coaching teaching. Okay, in this method the continuous path programming or the robot simulator must be there. Okay, so here we can say this robot should follow this path. Okay, so that means this robot must go from the point A to B, C to D, then D to E, and E to final at the goal. So these obstacles are placed in between this placed, so this robot must find out his path. Okay, and by considering these obstacles, and this robot must follow this path and it must go to this goal. Okay, so therefore continuous path programming it should be there. So it must sense these obstacles and it must generate his paths, and it must go to this its final goal position. So again, in case of this robot simulator, so this robot automatically senses these various obstacles and automatically generates its path. Okay, so that is nothing but the robot simulator language. So in programming, this continuous path programming and robot simulator can be done through this lead through teaching programming. Then some programming languages are also there that can be used. AL means it's assembly language, VAL variable assembly language, a manufacturing language, AML is also there. Okay, by using these various languages, programming languages, and again we can set the instructions to this robot and we can perform the various operations by this robot. So type of this robot programming. Okay. So there are three types of this robot programming: joint level programming, robot level programming, and high level programming. Okay. In case of this joint level programming, the basic instructions and basic actions are the positions of this individual joints, okay, or this movements. So in this joint level programming, the robotic arm, the basic instructions are provided to this robotic arm at the joints levels only. Okay, basic movements. And the joint angles are the instructions in case of this rotational joints, and linear positions in case of this linear or prismatic joints in the robots. Then second one, it is robot level programming. Okay, in this robot level programming, the basic actions are the positions and orientations of this robot. Okay, the position, hold the position of the robot, or the orientation, or the part that must follow that robot. Okay, so these instructions are provided in this robot level programming. So this robot must follow this complete, entire robot must follow these instructions, programming instructions. Okay, so that is called as robot level programming. And high level programming, in case of this high level programming, the object level programming or the task level programming must be there. Okay, so that means in this high level programming, the instructions are programmed in this robot, okay, to perform the various tasks. Okay, in the industries, to perform various tasks, the instructions are given to this robot in this high level programming language. Then classification of these robotic languages. Okay, so there are three types of these programming languages, robotic languages: first generation language, second generation language, and world modeling and task oriented object level language. Okay, so we will discuss one by one. In this first generation language, here we can see, so this first generation language is a offline programming language. Okay, it is a offline programming used in combination with this teach pendant. Okay, so variable assembly language is an example of this kind of this method. First kind of this first generation language. Okay, VAL is an example of this VA first generation language. In second generation language, AML and VAL second are these examples of this second generation language. And in this second generation language, the structural programming language performing complex tasks. Okay, to perform this complex task, some instructions, programming languages, programming instructions are given. Then apart from the straight line interpolation, performs complex motions. Okay, to perform these various complex motions, instead of this straight line, only straight line functions, so interpolating functions are also used to perform the various motion functions in this second generation language. Then again, this uses force, torque, and other sensors, okay, to in order to sense the input data and to perform the various tasks. Then data processing, file management, and keeping all the records is done in this second generation language. So this data processing and keeping all records is also possible with the help of this second generation language. Then in case of this world modeling and task oriented object level language, it is the more advanced language in the world modeling. Okay, then for example, the tighten the nut, in case of this assembly operations, we seen various robots are used to perform this, to assemble this components or assemble these machines. Okay, so in that, in order to tightening these nuts, some robots are used. Okay, so that the kind of this level of the language or the programming is required in the robot. So that is the world modeling, and or again we can say the task oriented language. Okay, then in this world modeling and task oriented language programming, intelligence is required. Okay, intelligence of the robot is required in this task oriented language. Then there are three basic modes of these operations of this robot: monitor mode, edit mode, and run or execute mode. Okay, so in these three basic modes, monitor, edit, and run or execute mode, this robot is always performing its instructions. Okay, so in case of this monitor mode, the programmer defines locations, load a particular information in a register, okay, saves the transfer programs from storage. Okay, so in the case of this monitor mode, the robot must move in back and front, and edit or run the objects. Okay, so similarly, in edit mode, the programmer can edit the or change the set of instructions. Okay, already defined instructions can be changed in edit mode of this robot, and run and execute mode. In case of this run and execute mode, the predefined tasks can be executed in run and execute mode. Okay, here in this mode, the programming or the set of instructions programmed in the robot. Okay, so that instructions are executed in this mode. Okay, so dry run can be tested or debugging can be done in this mode of this robot. Then we will see in detail VAL, variable assembly language. Okay, so the programming language and operating system which controls a robotic system. Okay, this robot or robotic system can be controlled by these various programming languages, okay, or various programs set of instructions. Okay, so VAL programs are also include subroutines which are separate programs. Okay, variable assembly language programs are the separate programs. We can, so locations. So in programming languages, some important points that we have to consider, okay, while defining these languages or defining the set of instructions. So these locations of this robot represent the position or orientation of the robotic tool. Okay, so from point to point or this path generating motion of this robot, so this location of this robot is represented by this position or oriented. Then two ways of representing these robot locations: precision point and Cartesian coordinates and orientation angles. Okay, in precision points, we have to define some uh, we have to define points. Okay, likewise x1 y1 to x2 y2, from x2 y2 to x3 y3. Likewise certain points we have to define. And in case of this Cartesian coordinates and orientation angles, so we can define a position, okay, with respect to some distance and with respect to some or angles as well as. Okay, then these are also called as transformations. Okay, these locations and these points are also called in the programming languages, these are also called as transformations. Then trajectory control, two methods to control the path of the robot. Okay, so in this trajectory control, there are two methods. One, it is interpolate between initial and final position, okay, producing a tooltip curve in space. And second one is move the robot tip in straight line path. Okay, so in this interpolation, interpolate the initial and final position of the robot tool tip, and it must move from a move in a straight line path. Okay. So in this, again, for the first case, that is here, from initial position to the final position, joint interpolated motion is there. Okay, that motion is called a joint interpolated motion. And in the second case, for the second case, the motion speed of the robot tooltip can be accurately controlled. Okay, in a straight line motion, this can be controlled very accurately. Then next one, it is monitor commands. Okay, so to enter and to execute a program, we have to use these monitor commands. Okay, these monitor commands are used in the robotic programming languages to enter this instruction set of instructions, and to execute this instructions, these monitor commands are required. Examples of these are defining and determining the locations. Okay, define the locations and determine the points or the locations of the robot. Okay, then editing programs, we have to fit these editing instructions in this through this monitor command. Then again, listing program and location data, storing and retrieving and location data. Okay, then all these can be controlled through this monitor commands. Program control can be also used, done by this monitor commands. Okay, now finally we will see the robot interaction language. Okay, that is Roelia, is the first spoken language called specifically for the talking to robots. Okay, so Roella is the first spoken language for these robots, and robot software is the set of coded commands or instructions that can be that tell a mechanical device an electronic system. Okay, and it is together this software and this mechanical system together it is called as robot. Okay, so robot software is nothing but the set of instructions, coded instructions and coded commands, and this mechanical device which perform the operations. Okay, and together both are called as robot. Thank you so much. Friends, thanks for watching this video. If you like this video, please share, comment and like this video, then subscribe to my YouTube channel and click on the bell icon to get notified for more videos on this CAD/CAM subject. And thanks for watching. Thank you so much.